Hello everyone again. Welcome to another Saturday live stream. Microbehunter here, Oliver, that's my name. And look, I got a little present from one of my viewers. These are Rheinberg filters for microscopy. And I would like to present them today to you and show them a little bit what little magic you're able to do with those Rheinberg filters. They're pretty nice, pretty neat, and you see quite a variation here. I would like to say thank you very much to Hadrian Meisenberger here in this chat. That's the name that he uses here. He sent them to me. Thank you very much again, and I can report back they work very well. Okay, so I would like to show them to you today. I've prepared a couple of specimens, mostly permanent slides that I've selected, which produce very good results here. Usually at the beginning of this live stream, I usually take my time, a few minutes, until people start to join in the chat. So a little bit of housekeeping information here. If you have any questions which is microscopy related, please do feel free to ask the question in the chat. I will try to answer it, or maybe you can also answer it. Maybe some of the viewers are able to answer them as well. If you have a specific comment for me, then please indicate this by putting an @ sign in front, @Microbehunter or @Oliver. So it's easier for me to find the comment. Okay, so what I'm going to do here is I'm going to quickly show you this one over here before I show you some of the filters. These here are starch grains from a potato. And I've now used a filter here, and and if you've already watched the last week's video, I also showed a little bit. I also was playing around a little bit with filters, with dark field filters and oblique illumination. But today I'm going to add a little bit more color. And if I basically swing out the filter holder in and out a little bit, look, I'm able to change the appearance quite a bit. And if you want to see how this looks like in regular bright field, then it will look like this. I have to turn down that's basically the regular bright field image, and that's a stained specimen of potato starch grains. So you can see that, just by adding a color filter, you're able to change the appearance quite a bit. Now, I do also have to tell you the following, that the image quality when looking through the eyepieces of the microscope is actually much better than what you're able to see here. Okay, the reason is that even though I do have a DSLR camera connected, it's a slightly older model, and I have I basically put over USB the signal into the computer, and unfortunately the older camera does not support full HD resolution. So the image quality is a little bit worse than actually if you were to look at it directly. So I just wanted to clarify that. And another reason why I'm using a DSLR camera is look, simply by turning a wheel, I'm able to immediately adjust the brightness of the image. So this is actually something for practical purposes here. Okay, I see that the sound is good, and I see that people have already started to comment here. Okay, great. So okay. So there is a question here. Do you have any experience using filters with ultra long working distance condensers? Unfortunately not. Okay. But I can tell you that the distance between the position of the condenser is quite important. I can actually try to show this to you. If I, for example, you maybe can also see at the top that I'm lowering the condenser here, right? And you see that actually this has a significant impact on the image quality as well. Okay. So what I'm going to do is I'm going to show you. I'm going to show you now a little bit some of those filters here and how they are put together. Look, there is a huge variation here. And I would like to also give you some recommendations here, at least as far as I know it. But maybe Hadrian is able also to make a few comments here. Look, this one is one that I just assembled today. So I would like to show them to you. First of all, those Rheinberg filters, basically, you can see that they have a colored disc in the center, and on the outside a periphery of a different color. So it's here. This is a dark field filter that I made. So it's basically a variation of dark field. but the images look quite a bit more different. And what you can do is now you can combine, of course, different colors. For example, of course, blue in the back, in the center, and red on the back. Here, this one over here is, I don't even know what. This is very dark blue and yellow. Okay, and you see that sometimes there are those rings here which are completely empty, and then you're able, and this is a little bit thicker here, you're able to push one of these things in here, and you're able to make your own color combinations this way, right? Sometimes if you want to change the intensity of the color, you might want to stack several on top of each other, okay? Yeah, so right now it's simply friction holds it in place. Yeah, and this one, of course, green and yellow, and there are, of course, others as well. For example, over here, yeah, blue and red. Here again, yeah, completely yellow discs. Yeah, red, blue. Yeah, the clear ones as well. Yeah, so you see there are a wider range of different combinations that you can try. However, as a general rule of thumb, yeah, and that's basically one of those. Foils that's used. Apparently, they are used to, if you want to change the color of lights, of lamps, right? Then you can actually use those. So what I've done, however, in the past, several years ago, when I also tried this, I tried to print them using color laser or inkjet on overhead foil. This also kind of works, but has the disadvantage that the intensity is not quite as high. And so sometimes you have to print it over several times. So I think that this is quite an easier way. And how do you get those circles? They were punched out. Yeah, and if you you can of course also cut them out yourself. But one of the things that's really critical is and that's where you have to experiment around is that the size of the central disc has to be correct. Because if it is too small, you're not going to get a very strong effect. Yeah. So in case of doubt, it's probably better to make it a little bit larger to basically err on the larger size, right? It will basically make everything a little bit darker, but at least you will get a good contrast. Yeah? And you can basically choose any color combinations. And the thing is that not all color combinations. Not all specimens are suitable. And I'm going to show you a couple of those specimens. Okay. So what I'm going to do every now and then is of course, I'm going to check. I'm going to interrupt myself, and every now and then I'm going to check some of the comments here. Okay. There's a question here. Will you be buying any more antique slides again, or have more to show? This question refers to one of my previous live streams where I showed some antique slides. And I basically have, I think, around 10 of them I bought. I showed them to you already, but I can buy more, of course, if you're interested. So if you want me to do that, then I'm going to get some more of the antique slides, of course. I'm going to start building up my slide collection. So there is also a comment here. I bought some nice Rheinberg filters on eBay, but they were a little thick to use. To fill into my filter holder, I need to make my own with thick acetate. So I wanted to just also show you now a little bit of another thing here. Those filters here, they have a fairly, I want to say maybe 1 or 2 millimeter thick central plastic disc. So when I put them in, what I do is I always put it in with the thick side pointing downwards so that I can actually swing it into position, right? So what I'm going to simply do is I'm going to just show you now how those specimens look like using different filter combinations, okay? And then let's have a little bit of fun here. So what I'll do is I'll switch back over here. These are again the starch grains, and in case you were not here in last week's live stream, look, if I swing out the filter holder a little bit, you will actually see, maybe at a higher magnification, you might actually see that it does appear to cast a shadow, okay? You see it becomes darker as well, but it looks almost a little bit three-dimensional. So this is a combination of Rheinberg and oblique illumination, actually. So I'm going to adjust this. So there are really a lot of things. So my general recommendation is, because I receive a lot of emails of people who want to upgrade their microscopes, before you buy any new optics, and try to upgrade anything this way, my recommendation is that you play around first and by making a couple of filters. By the way, that's how the the starch grains, turn down the intensity. That's how the starch grains look like in regular bright field. Yeah. So the filter that I used in this case, was a blue yellow one. Okay. So what I'm gonna do now is let's try now the red blue one. Okay. I just show this to you here. That's the other one. Yeah. I'm going to try to use this one now. And then I've got about 10 or 12 slides that are prepared. Yeah. I have to insert this. And of course it's going to be quite dark, so I have to turn up the light, and then I have to try to find the correct position here, right? Yeah, but sometimes at a lower magnification the images look a little bit better. You always refocus, and you start to open it up again. Yeah, so that's basically a blue-red combination, right? So, that is essentially one of the nice things about Rheinberg is that you can get, especially if you want to make YouTube videos or so, you can add some color to the specimens without actually having to stain it. And in some cases, it indeed does improve the contrast and makes things visible that otherwise you would not able to see. Yeah? Could the heat of the halogen lamps be problems for these filters? And the short answer is yes, maybe. I can say that because I tried several years ago. It depends on the material that you use. Okay, and I'm saying this because a couple of years ago I tried using homemade filters using my microscope with a halogen lamp, and I actually felt that the filters got quite hot. So I recommend that you use, I used filters that are printed using laser on overhead copying foil. And this foil is relatively heat resistant, but I did feel that the one that is used for inkjet, so I kind of printed the filters, I made the filters in PowerPoint and then I printed it on inkjet, and this overhead foil was not heat resistant, so it actually started to become soft and melt a little bit. Yeah, so it indeed is, it might be an issue. I would probably say that if the filter is in air, so to say, if there's air on top of and the bottom, probably the heat is able to escape. But actually, I have to admit, I was a little bit surprised how hot the filters became in a halogen microscope. Yeah, so it is indeed a heat issue didn't exist. Yeah. So why do these filters have two different colors? Thank you for asking. I didn't explain this. Okay, I did not explain this, and this is something that I have to do now. Okay, and no, that's the wrong one here. So I will explain this here. What happens is the following: is that if you put this filter into the filter holder of the condenser, so this only works if your microscope has a condenser, and pretty much all microscopes with a condenser also have a filter holder. Sometimes this filter holder might not be easily visible because it's a swing out one, and you have to just search, and then all of a sudden you're going to discover that this is a swing out thing. I don't even know if I'm able to show this to you, and then this where is this? Oh yeah, you can check at the top. Yeah. So I'm going to just show you. There is this. Now it's the bottom of the microscope here, right? Yeah. And sometimes I even got emails. Some people were not able to see anything because the filter was kind of stuck halfway and kind of blocked the light, because the ring of the filter kind of blocked the light, and they thought that the microscope was broken. It actually was just that the filter was not in place, right? And this filter holder. Yeah, maybe I have to go on the top. Yeah, there is a filter. The filter is in here, right? Yeah. And what is really important now, and this kind of tries to answer your question, is that when you put the filter in place, and because there's an optics in here, yeah, what will happen is that the central part of the filter will become the background. So the background here would be blue, and the specimen, provided that it's able to refract and redirect the light sufficiently well, will have the color of the periphery here. Okay, so what you're able to do is you're able to change this way the color of the background and the color of the cells that you want to look at. And maybe because the ones here is not the best type of specimen to illustrate this, I'm going to take this out. I'm going to show you a different one. I did prepare Yeah, what 12 slides here? I don't know. What's another one? Yeah, for example, this one over here. I already showed them to you last time. Radiolaria. Okay, so these are radiolarians. These are the shells of yeah. So and yeah, I don't know. Let's just use this here as an example. Let's open it up a little bit. Okay, and now you see that the background is blue and the specimen is red. Okay, yeah, so these are the silica shells of some marine radiolarians. Again, I do admit it looks maybe not quite as crisp, but under the microscope it does look much better than what we have here. Okay, I have to where are more? Here are some more. Actually, just a second. Let me. I'm now checking the microscope directly. I'm going to find here. Yeah, that's the one that I. Here, this one for example. Okay. Yeah. So you see that the specimen itself is red, but let's go up with the magnification. Okay. I'm going to try to readjust the filter again. Yeah. The depth of field is also kind of low, right? Yeah. So if I refocus, I would have to do some image stacking here, right? But here, this is the silica shell of a radiolarian, and you see that it looks reddish, and the background is blue, right? Yeah, I'm trying to readjust. Yeah. So yeah, so I'm going to change now the filter. Okay, and now I'm going to put in a blue-yellow one. This was a red-blue one, and now the center is blue and the periphery is yellow. And this is how it looks here. Yeah. So now you see the background is blue and the specimen is yellow. Yeah. And that's why it's a good idea always to make sure that the central part is darker, because then you see the specimens brighter on a slightly darker background. Now this technique is of course very related to dark field. So this is a dark field ring, okay? Basically it completely makes it black, it's like black-white, so to say. And I will just show you how it looks like with dark field, yeah, which is of course the highly related technique here. But yeah, if you do it with dark field like this, it's also okay, but sometimes I think the contrast is a little bit too high. Yeah? And dark field is also very dust sensitive. So as soon as you have a little bit of dust somewhere in the optical system, it's going to start to light up. Yeah. So yeah, and because yeah, the Rheinberg is not quite as dust sensitive, because even the background is not, because the background is not completely dark. Yeah? Yeah, so. Yeah, so this is kind of it's called optical staining. Yeah, so I see again a whole bunch of comments here. Can I do that if I don't have a filter holder? What you can try to do is, well, you do need a condenser. What you can try to do, and maybe I'm going to try that as well, is you can try to kind of place it maybe directly over the lamp and kind of move it up. Okay, so let me try this. I've never tried this before. Okay. So I'm going to remove now the filter holder. Okay, let's turn it down a little bit so that's not bright field. I'm going to put now the thing directly over the lamp. Yes, it does work. Okay. So that's basically, I'm now kind of holding it over the lamp somehow. Okay. And that maybe this also kind of works. Yeah. But I think you do need a condenser, because it's really important that the specimen receives the light from the side. Yeah? So the idea is again like the following, that if you look at it from the side, maybe if I have a specimen over here, right, then the main light that goes through here will become blue. But the light that comes from the side will not be able to reach the objective directly. It kind of bypasses the objective. But if there is a specimen in here, then the light will be the light will jump off from the specimen into the objective. So the yellow light here from the side, yeah, will illuminate the specimen from the side. It's a little bit like if you are in a dark room and you have a flashlight, and then you see the dust. You see the dust flying in the lamp of the flashlight, right? The dust will also appear to be bright on a darker background. That's because you're not shining the flashlight directly into your eyes. Yeah? So that's a little bit the principle here. Yeah. Yeah, it's an interesting one. Dark field is magical. Oblique is also a lot of fun. It's a shame it took me 20 years after college to learn how to do it, either one in a basic scope. Okay, let's put it this way. There are a whole bunch of other possibilities that you might want to try, and that is, for example, people have been using also polarized filters, right? You can try that, or other variations, like for example having this one over here. It's something that I try to make. Yeah, it has been recommended that you make those filters like this, because it will scatter the light depending on which way the specimen scatters the light. Parts will be yellow in one direction and red into the other direction, right? So again, it is a kind of very specific for the specimen. Yeah. Is there a way to make a phase contrast filter? That's the following. You can make, of course, phase contrast filters. You have to really measure this out. However, this will not give you phase contrast unless you also have phase contrast objectives. Okay, so this is the really difficult thing is actually you need phase contrast objectives, and then you are able to actually make your own, not with color. I don't even know where I put it now. Oh yeah, here. But you're able to make your own phase contrast filters by having a ring of light here. But this has to be really carefully measured out. Yeah, and I know that this is possible because some people have done that, and I've read some reports online. But it's not the easiest thing to do. Yeah, yeah. Okay. So what I'm going to do now is I'm going to show you a few more things. Okay. So this is these are the radiolarians, and what else do I have here? We can try some red yellow maybe. Okay. I'm going to switch over again. Yeah. Red yellow. So I'm going to swing it out, and let's put red yellow in here. Yeah, that's red yellow. It's actually really nice. Again, I have to tell you, it's I don't know what to do with the camera, but it's so much more, looks so much nicer if you actually look directly through the microscope. Yeah, it does look quite fuzzy. Some image stacking wouldn't hurt here. Yeah. Yeah, but through the microscope, it's actually way better, right? So now what happens if you don't see anything? You have to open the condenser all the way, okay? So that's the thing there. If you close the condenser diaphragm, look what happens. Right? Of course, you're taking away the light, right? This is also maybe one of the reasons why it might appear to be a little bit low in contrast and especially low in depth of field, because the condenser has to be open all the time. Yeah, that's a little bit the thing. Yeah. So it's quite nice. One thing I did not try yet, but this has been also a recommendation or comment, is use a so-called if you use polarization filters, then there are so-called lambda fourth plates or so-called retardation plates, and what they do is they shift the wavelength by, let's say, a quarter of a wavelength, and apparently with those you're also able to do a little bit of color changes. But I've not tried that because I don't have those separate so-called retardation plates. They're called like that because they're kind of retarding or pulling back or shifting the wavelength by a quarter of a wavelength. Yeah? Or at least they're shifting the so-called electrical and the magnetical field of a light wave, and then you can get the color changes. Yeah. What's the difference between a dark field filter and a dark field condenser? Yeah, so this question is also a common one, which was also asked, I think, last week already. It's because you do see in some cases that companies sell separate dark field condensers, and here we gotta be a little bit careful. This is not a, by the way, this is not a yellow one, you know. Oh, it's also here. You know what I'm going to do is I'm just going to go back here to the desk here while I answer the question. Basically, this is a dark. These discs here, these homemade discs, can be put into pretty much any filter holder of a regular condenser. However, they have a disadvantage, and the disadvantage is that they take away a lot of light. So yeah, of course, because it blocks a lot of light, and therefore the only light that you get is the light that kind of indirectly illuminates the specimen from the side. Yeah, and if you now go to higher magnifications, 40 times, 60 times, and so on, then those higher magnifications are already very dark. And then, but you have to make the disc even wider, otherwise you're not going to get a dark background. So this basically means you have two ways in which you're actually reducing the light. You're going up with the magnification, and you have to make the central disk larger. And this basically means that this there is a certain limit that yeah, which is practically possible with those filters. But if you now need a dark field also at a very high magnification, then you have the option of either illuminating the specimen from the top. This is super expensive. You need a special microscope which basically has a lamp at the top, and the light is redirected down the tube through the objective. There is a separate light path inside the objective to illuminate the specimen from the top, and in the center you have the lens where you can actually look at it, right? So the light is coming from the top, and you're also viewing it from the top, right? This is like in UV in fluorescent microscopy. You're using a similar technique. That's expensive, right? There are now also other possibilities where you're using a condenser which does not have a disc, but which has a concave mirror system. So what happens is that the light which comes from the bottom, right, bounces against the concave mirror in the condenser and is redirected diagonally away. Yeah? So you're gathering much more light this way. However, I'm not sure if those comparatively low-cost condensers that you can buy, dark field condensers that you can buy, if they actually do contain this concave mirror, or whether they not also have a built-in disc. Yeah, so I don't know about that. Yeah, so that's something that you have to one has to look specifically. I know there are some dark field condensers, but one has to check. Do they just also contain a normal disc, or is it really like this that they contain a concave mirror system, which must be quite expensive to manufacture? Yeah. So let's go down here again. How do you choose the best diameter of this middle part? Yeah, that's that's a thing that has caused me quite a bit of headache. Short answer: experimentation. If you do check my other channel called Microbehunter Microscopy, I did make a few videos about making your and 3D printing those filters. You don't have to 3D print those, but it was simply easier to make it like this. And yeah, really, I made, I don't know, 10, 15 of those filters, always changing the diameter a little bit until I found the one that actually worked well. Okay, so there has to be a minimum size, and yeah, so experimentation is, I think, the best, and always make sure that the condenser is always all the way on top. Okay. The red bloom is tricky in DSLR and mirrorless cams. Solar scopes using H-alpha make very red images that look muddy in red. These cams, yeah, generally, then yeah. Also, if the red wavelength. If you don't like usually halogen lamps also have a lot of red component, then you might want to use a blue filter. If you want to choose your specimen color and surrounding, you're best to use non-stained objects, right? Or else you have to consider to mix between your color and the stains. So the thing is the following: there are so many variables involved that I wouldn't even be able to give you a simple answer. For example, the specimens that I showed you here. Let's go back here before I show you some of the others. Yeah. This one here is actually a stained specimen of starch grains. Okay, so you see that the cell wall is stained blue. I don't know which blue they used, methylene blue. And the starch grains are purple, pink. Okay, so this is a stained specimen. And if I now use a filter, okay, let me see. Yeah. Then over here, well, this one over here starts to look like this. But the one that I used before was the yellow-blue one. Huh? Was the yellow? This is this is this one over here. This is the one with the with the squares. But this is the yellow-blue one. And I think this looks again quite pretty because the starch grains have a bright halo around them. Right, so it actually does increase the contrast. Yeah? Then if you were to use the green, let's say a green, let me use now a green-yellow one. Okay. Then it looks like this. If you open it a little bit. Huh? Yeah, so of course you were getting some kind of a mix between the color filters, the Rheinberg filters, and the actual natural color of the specimen. However, what I think is the interesting thing is when you're using actually specimens that do not contain a color, right? For example, those radiolarians, or for example, I've got a whole bunch of others here. Where's this? Let me see. Yeah, the diatoms here. Okay, let me show you those. Again, this is that's completely without filter. Let's close the. Okay, let's close the diaphragm here to increase the contrast. Okay, so these are some kind of marine diatom shells. Okay, they appear to be dark on a bright background because they of course refract the light away. Let's add now a filter. Let's say the blue-yellow one. You turn up the light. I try to find the correct position here. I have to, of course, raise everything. Just a second. I have to open the condenser. You always open the condenser. I forgot to open it, and this is how it looks like. Huh? It kind of looks a little bit blurred, blown out because it's too bright, right? Huh? So let's compare this again. So that is with the filter, and that is without the filter. Okay, so you do see a pretty significant change here. So it's called optical staining, and of course is quite nice to get color into it if you're not able to use chemical stains. Why not? Because chemical stains, of course, sometimes destroy or kill a specimen. So I changed now the magnification. Now the challenge is, of course, again to find an object here. Okay, that's a fragment. Let's try to focus this again. Yeah, here. So now I'm using the 40 times objective. Oh, maybe this one over here is better. Okay. You do see that there is again a little bit of an oblique effect here that I have because it looks a little bit three-dimensional. But let's move it in here. Yeah, and then we have it bright yellow on a bluish background. Yeah. Because, so let's try a different one. It's the blue-yellow one. Let's try the yellow-green one. Let's see yellow-green. In this case, what I probably would do if I were to see it like that, I mean, that looks nice, but maybe the contrast is not quite as high as with the blue-yellow one. And in this case, I would make the central part a little bit darker. So I would simply add another one of the green foils over it, yeah, to make the green a little bit darker. Then, yeah, there is a bigger contrast. And what do we have next here? What is this here? Ah, yeah, red, blue, for example. And yeah, that's the red-blue one. Okay, we have to turn it up a little bit, the lamp. You get the idea. Background is blue, specimen is red. Yeah. So, how to choose the best diameter of this middle part? Yeah, that's what I just said is experimentation. I really would do that because, yeah. Because it did find out that it can be quite a bit sensitive, yeah, the diameter, and sometimes, like for example, in my case, I even have to find the correct position here by kind of yeah, rotating the filter holder out and in a little bit. So a possible use for this technique of optical staining with colored filters is the observation of living specimens in order to avoid killing them with dye, isn't it? Sure. I don't know if there's still some liquid left over here, but let me try this one. Or I'm going to just make an. Let me see. Usually with water organisms, I like to have blue as a background, and usually. Okay, it's not blue, but I have to tell you, I don't even know if they're. I mean, I prepared this last hour, so it could be that it's all dried up already. There were some water microbes and some rotifers in here. But see, it's already all dried up. I think I have to prepare a new specimen. Ah, there's some remaining, yeah, algae and so on. Yeah, there is stuff moving in here, but it's too small to see. Okay, let's go up here. Ah, not good. Ah, yeah, here we go. Now, there's a rotifer here as well. Okay, where is it here? Yeah, so there are a couple of, yeah. Paramecium. Okay. Maybe I'll turn up the, no, I'll make it exposure time a little bit. Again, it looks a little bit not quite as good as if you were to look at it directly under the microscope. Yeah? So if this is kind of the stuff that you want to do a little bit, yeah, here a little bit oblique. Yeah? And in bright field, as a comparison, I take the filter out. I have to go down with the light intensity. It looks very low in contrast because the condenser aperture diaphragm is open. So I close the diaphragm. Okay, this is how it looks like in completely natural colors. Okay, it does look more crisp and sharp now because I'm closing the condenser, and therefore you're increasing the contrast, of course, and also the depth of field. Yeah, and therefore it gives you a more subjectively a more crisp look, but yeah, again, if you want to use colors, then that's when you use the filter again, and I have to turn up everything, and I have to open the condenser, and then I have something like this again. Okay, yeah, so just for comparison here. Nice. I can never find radial diatoms in my area, only diatoms with bilateral symmetry or occasional basilaria. Radial diatoms, to my knowledge, are mostly marine. Okay, so if you try to find get some marine sand samples or so, mostly they have round diatoms. Okay, so yeah. So it's been a long time since we looked at the water specimens. Yeah, yeah. But maybe most of the times you can see it better in dark field. Yeah, we can try this as well. So this is now basically a little bit with this with Rheinberg, and now I'm going to exchange it, and I'm going to now completely take it out, put in a dark field filter, and this is how it looks like in dark field. Yeah. Again, here you see, because this filter is a little bit off center, for this reason, those bubbles that you see, they appear to be like casting a shadow a little bit. Yeah. So I just want to show you a couple of other specimens, maybe. So let me put this one away here. So I looked at those. We looked at the potato. Let me check a little bit the time. So there's something interesting here as well. This is a pear, a pear fruit. And these plant cells are a little bit challenging, because I'm just going to be using now red, blue, yellow. And but I did see something quite interesting. I have to put it in here. So, and everything is on the top. I have to kind of find the focus, and I have to make sure that, just a second, I have to open up everything here again. Okay. And while it does not appear to be so nice looking as the other one, so that is the cross section of a pear, I still want to demonstrate something to you here, because it can be used to differentiate different cell types. So I'm going to give you now an image first of how it looks like completely under normal bright field. Okay, so that's basically how the specimen looks like in bright field. Okay, you can see the cell walls of the cells, right? But if you add the filter now, and you have to go up, you see that some of the cells start to light up a little bit. And some cells start to become brighter, earlier than others, and these seem to be so-called sclerids, in German Steinzellen. And these are cells that have a very thick cell wall, and if you eat a pear, then it has sometimes this gritty feeling in your teeth, like you're biting on something hard. These are those cells here. And what they do is they seem to refract the light much better than the other cells, and that's why they appear to be brighter than the other cells. And that is something that we're able to see in Rheinberg and also in dark field, but we're not able to differentiate that so much if we just open up the condenser. Then basically we see everything here, right? But those cells which are now in the center, they do not shine up. Yeah. So, and when you're now using the filter, then you see that they appear to be brighter, because I think of the thicker cell wall, they're able to reflect the light better. So I just wanted to, I know even though this is probably not the most exciting specimen, I just wanted to show to you that there can be, just besides making it appear beautiful, Rheinberg can also be used to distinguish different types of cells. I'll quickly go through the comments here. What is, I'm not able to follow now the conversation. We can ask Oliver whether it is okay to give you a mail address for contact. I'm not able to follow now. Somebody wants to contact me, I guess. I didn't read all of the comments, so I don't really know exactly what the conversation is about, but I'll read it later maybe. So if these filters remove the need for stains, would this allow you to see a nucleus of a cell instead of methylene blue? Possibly not. The reason is because when you use methylene blue, you're actually chemically staining DNA. So methylene blue is quite specific also, and stains DNA very well, while this optical staining does not look so much at the chemical composition, but more on how the specimen interacts with the light. Okay, so it could be that the nucleus is just as invisible because the light does not bounce off the nucleus, right? So it cannot replace chemical staining. Yeah, but under certain circumstances, yeah, it can make things appear nice. So what I just want to say is this is just one element of, or one aspect of a whole repertoire of different techniques, which you have to simply choose depending on the specimen that you want to look at, right? So this here, for example, here that's wood. Okay, that's wood, for example. Yeah, it's opened up, and we're able to see the wood has very thick, cell walls, and therefore we're able to see it quite well. How does it look like without a filter? I always have to turn down the light intensity again. This is how it looks without a filter. Okay, maybe I have to close again the diaphragm. So without a filter, natural colors. Okay, and here again. And I know I'm repeating myself, but it looks so much better when looking directly through the microscope. Yeah, so there is indeed a little bit of loss of resolution because I also had to zoom in quite a bit to make sure that the camera image fills out nearly the whole screen. Yeah, so really try it out. It's really quite nice. Yeah. So what's the difference between LED and halogen lamp? Sorry for the newbie question. I'm weighing up a new microscope as you've got me hooked. Okay. Let's put it this way. The different. Okay, let's put it this way. The LEDs does have the advantage that it does not produce as much heat. Okay. So that's certainly a significant advantage. And if you do photography through the microscope, then by changing the light intensity of the LED, you do not change the color temperature. But halogen generally produces more heat, also produces a more reddish color. And if you change the brightness, then if you at low light levels of halogen, for example, the lamp is more red, and if you turn up the brightness, it becomes more blue. This can be a little bit of an issue concerning white balance sometimes, right? There is a little bit, for some people, it's a question of taste. I've heard that some medical doctors who have been trained for many years using halogen microscopes, they prefer to stick to the halogen-like lamps, right? But many modern microscope manufacturers have switched over to LEDs. Generally, what I would say is that it's to a certain extent probably a question of taste. Yeah, but I would say that LEDs probably are the more modern system. And however, I have found, especially with some especially cheaper microscope manufacturers, it might become difficult to actually finding replacement LEDs. Yeah. While there are still low-cost replacement halogen bulbs available. So that's kind of a little bit, but I would say there is, maybe there are other factors that are more important, okay, than whether it's halogen or LED. To a certain extent, a little bit of a question of taste, but I would say that, of course, LEDs are definitely the more modern way. Yeah, I did not realize that wood had so many spaces. Well, these are the cells, right? In the sample now, it has a lot of spaces. Is that the case in living wood too? Well, it depends which part of the wood you're looking at, because indeed the wood carries water, and many of the cells, especially the central part of the cells in wood, are dead. But there are long tubes that are therefore carrying water. Right. Generally, the outer part of the wood is the living part, and and another thing that's important to know here is, of course, that this is a prepared sample, so it has been cut, and anything that is in the cell, if there was anything in there, has already been removed. But generally, if you, for example, take some wood and cut it yourself, you're also going to see those structures and those spaces, as you say. Robert Hooke, back in the day, a couple of 100 years ago, when he put cork under the microscope, he also saw those little spaces, and he compared them to the spaces of a honeycomb. And Robert Hooke, when he saw those spaces, as you mentioned, he called them cells. Yeah, and of course at that time he didn't know what they actually are. Yeah, but yeah. Why is it so difficult to find a way to take photos and videos in microscopy? It's a world full of expensive cameras and adapters, and nothing seems to be decent. Yeah, I have to, unfortunately. I understand what you mean. Okay, and I think there are several factors for this. All right. First of all, I just want to show this to you, maybe. So the square scope. I'm going to the desk view because I've got my DSLR now connected. Huh? So one of those USB micro. It's a 5 megapixel USB 2.0 microscope camera. Yeah. So yeah. USB over here connects directly to the computer, so it's a power supply it receives, and yeah, you can control everything over the computer. There's some optics in here, and I'm going to show you now something. When you open do you see this tiny thing in here? That is the sensor, right? And generally small sensors do not provide a very good image quality because the signal to noise ratio is not very good, and so on. And you also have optics in here, and the optics, they kind of focus the light in such a way that you're able to fit the image on the sensor, and the optics also degrades the image quality. Yeah? So that is already a problem, and the small sensor is a problem. And then you have a slow USB connection. So this means you do not get a high frame rate for video. It's good, it's fine if you want to take still images, right? But the camera connection is slow, so unless you have USB 3.0, right? So there are multiple factors, but these cameras have one important advantage, and they're really convenient. All you do is you kind of drop it in. Even if you do not have a photo tube, if you want to drop it into the eyepiece, you can do that. Yeah, they're sufficiently light that in most cases the microscope won't tip over. But they too cost a couple of hundred. Yeah, there's even for a tripod here. So this is a little bit of thing. So I do understand what you mean, and especially if you want to connect the DSLR camera, then you need a DSLR adapter, which degrades the image quality again. So generally, if you really want to have a very good out-of-the-box solution, then you probably have to go to a manufacturer, to the more expensive manufacturers, because they will make sure that everything is designed in a proper way. And for example, the microscope, not this one that I'm using right now, but the other one that I have, is designed in such a way that there are not even any optics between the camera and the objective. Yeah, so the objectives directly project the image directly into the camera sensor, so to make sure that there's absolutely no loss of image quality. Right. So this is a little bit of an issue. Yeah, I get it. Yeah. Why is it like this in 2024? We have so advanced CMOS sensors in smartphones. I'll never understand this. I tell you the following. It's ironic. I get it. It's ironic. I've been able to produce better images using my smartphone, taking smartphone pictures through the eyepieces than with some camera combinations and DSLR combinations. It's ironic, right? And the reason is because there's so many factors involved, right? Like I don't know, the optics and the camera sensor size and so many other factors. So it's indeed, when people ask me what's the best combination, I'm almost a little bit afraid of giving an advice, because it might be so different from microscope to microscope, right? So I always say is you got to try it out, and if you're happy with it, for example, it's interesting. I tried to connect my DSLR camera to my stereo microscope. I'm using the same adapter. The image quality is horrible, really, because somehow the microscope optics and the adapter optics, they don't cooperate well. So it's really a fuzzy, a blurry image. Right? And then I discovered another reason is because there is so much empty magnification added. So you see, and that makes it really difficult to give certain advice here. And generally what I say is, if you want to take occasional images through your microscope, maybe try to connect a mobile phone. But then again, that's not very stable either. Yeah? So each system has its own disadvantages and advantages. Yeah? So that's another wood. Okay. And here I like this one a lot. Okay. So let me turn up again using the blue yellow filter. What you're able to see here. Now I'm going to switch on the arrow. Yeah, do you see those? Yeah, the cells are dense here. These are the annual rings. So basically, these are the rings of a wood, right? Yeah, as they're growing, and these are of course also cells for transporting of substances. Yeah? So, and you probably again want to see how does this look like in original. Yeah, and that's how it looks like in original. Again, you might say there are more details visible here. That might be. Because I'm also closing the condenser and this increases the contrast. So, and I just want to say is probably before trying any fancy upgrades or thing, try playing around a little bit with color filters. Of course it doesn't work. I have to open the condenser again, and here we go. Okay. I have to turn down the lamp. See how some cells start to light up first before the others? Yeah. Tells you a little bit also something maybe about the ability to reflect the light. But you know what? Why not try? I didn't try that yet. What about red yellow? Let's see how red yellow works. Yeah, that's red yellow. Okay, and we also have green yellow. Generally, for water samples, I like the backgrounds to be blue because this kind of gives a little bit the illusion of water. Yeah, that's not green yellow. Again, this is kind of I have to adjust the yeah. You get the idea. So. I guess iPhone and Mac would be the one to go for. There is one thing, I don't have it here now, but I did make a review. There's one adapter specifically for the iPhone, which works quite well, but the problem is it's also quite expensive. Yeah. So some of the mobile phone adapters, that's dark field now, some of the mobile phone adapters almost as expensive as a separate camera. My Swift Eastview app for my camera is free, but the contrast isn't good, and it gives extra magnification for some simple specimens. It's fine, but for a sample with movement, it's quite laggy. Yeah, that is the laggy part is the low frame rate. So what you would like to do is in the app, try the following: go up with the gain, go down with the exposure time. Okay. So this might actually, and go down with the resolution. So if you really want to have smooth video, a low resolution, high gain, short exposure time. Yeah. Again, a lot of experimentation here. So I want to show you some other stuff here. That is it's a permanent mount of of an algae. Okay. So let me change this here. Let me use just regular bright field. It says you just some algae that were prepared. Again, probably probably the here a fresh specimen would be probably better. I'm kind of surprised. I mean, those slides here are quite old. Yeah, several decades old. I'm still kind of surprised that it was able to keep the green color of the chlorophyll. So let's now, being a water sample, let's use blue yellow again. And then of course we have now a mix between the chlorophyll and also the background. So that's basically, that's how we're giving it a little bit. So we're now shining the yellow, the algae is now yellow, it mixes with the natural color green, and the background is now of course blue, as you can see here. Yeah. So that is the, So, I don't know, that's the 4 times, let's try the 10 times. Yep. Yeah, because the condenser, of course, is open. Therefore, of course, the depth of field is fairly low. If I do it like this, let's see. Then here we have, this would be dark field. Why am I able to get dark field like this? That's a little bit of a trick. Because I now placed the filter holder has a plastic ring on the outside, right? And if I just move the edge of the filter holder into the light path, then it acts a little bit like a dark field filter. It's a pure coincidence. Yeah. So simply the holder, the plastic ring on the outside is when it's kind of in the center, looks it gives you by coincidence a dark field effect. Yeah. Which magnification? Yeah, I'm using now 10 times. So you know what? That's actually something I can just show you as well. So this is now the 4 times. Okay, so that's the lowest. 10 times, and anything more than 10 times, is that's now 40 times. Yeah, and this is how it looks like. And see, that's the reason why the central disk has to be the correct size. Otherwise, we're not getting the proper effect. So maybe by recentering it a little bit, I'm able to get it. Yeah. So exactly. Yeah. You see that this is already getting delicate. Now I've got again the blue background, but you see that everything becomes darker. So I'm going to adjust the camera now. I'm going to go up with the exposure time. Yeah. So, and of course, going yet higher with the oil immersion or so, that's something that would probably not produce any decent result. Yeah. What medium was the algae mounted in? Impressive that it hasn't lost color. Yes. Unfortunately, it doesn't say which mounting medium was used, but I'm quite sure. Well, actually, I'm not even so sure anymore. Normally, you use for water life, you use glycerol jelly or glycerin gelatin. Because it is a water-based mounting medium, because if you use any mounting medium that contains some kind of an organic solvent, then this solvent would actually dissolve the chlorophyll pigment, the green pigment, and then is definitely gonna lose the color. And I say that I'm not even sure anymore if this is glycerin jelly, because usually if you have a slide with glycerol gelatin, then the slide is ringed. I'm going to show you what a ringed slide looks like. Look, a ringed, so I'm going to switch over here. This is a ringed slide, and if you use glycerin gelatin, you have to put a ring around it because you have to protect the glycerin gelatin from actually either completely drying out completely or by absorbing moisture, right? And also to add stability, physical stability, right? But the one that I'm just showing you, this one over here, actually does not have a ring. So I'm not even sure whether this is actually mounted in glycerol gelatin. So, but okay, so this is I've got another one over here. Let me try this one, just because I haven't tried it yet. So this is the blue yellow one. So this is another yellow one. Let's see. It's also seems to be purplish. It also looks okay. Would people stain algae green to preserve that natural color? I wonder. I don't think so. So that is, I don't think that it wouldn't make a lot of sense to stain it green. Generally, what I would say is that because algae are not so difficult to obtain anyway, and for casual microscopy, you just keep a jar. Maybe 20 times is maximum. Yeah, that's the question. If 20 times is the maximum meaningful, I think so as well. I have done a little bit of dark field microscopy and also a Rheinberg with 40 times, but this is really kind of stretching it already. And then you have to go up with the exposure time so much or with the gain, and then the image quality drops again. Yeah. So. So, yes. But your slide is old, you say? Yes, the slides here that I've got here, I've yeah, borrowed from my school because I'm a teacher. And I think they've been around now I mean, I'm teaching now for 25 years there, and we've used those slides since then. Yeah. And I mean, a couple of weeks ago, I actually showed you some slides that are over 100 years old. I bought some antique slides. They were over 100 years old, and honestly, they were probably even better than some of the modern ones that you're able to buy. They were really nice. Yeah? So there is, if properly made, there isn't actually no reason. There is no reason for them to actually degrade. But it really depends a lot on how much time was taken to properly prepare them and to properly dehydrate. Yeah. Yeah, this is the flea. It's one of my favorite ones. Okay, just want to show this to you again. Also, let's let's keep this one, this blue-yellow one in there. Okay, I have to go down with the magnification. Now I have to find it. See, that's all the dust and dirt that's in the background. Here is the flea, a dog flea. Okay, so yeah, you see that essentially, yeah, the background is blue, but the flea is also in darkness. Look. Okay. Now it's better. And then, of course, we're able to see certain structures in a way that we normally would not be able to see them. So actually, it does look a little bit similar to my DIC contrasting technique. So in comparison, how does this look now like in regular bright field? This is how it looks like in regular bright field. Okay. I have not changed any condenser settings. Okay. It does look a little bit soft because the condenser is open. But now I'm rotating the filter into position again. I'm rotating and okay. Where is it? Yeah, here we go. A little bit obliquish now. Yeah. And we're now able even inside, we're able to see some of the details that we were not able to see. Why am I not able to get the blue again? Here we are. I have to turn up the light. Yeah. Yeah. Look, yeah. And one of the things that I really like a lot here is, of course, the following. Just a second. Because we're looking here at a hole mount. And you might be able, let me show you now a little bit of biology as well. Look, here's the arrow. Do you actually see inside the legs those structures? Yeah, in here. Like those lines here. Yeah, and also over here. These are muscles. Yeah, inside the insect. And if I open it up again, and then we're not by far not able to see them quite as well. And again with the filter, we're able to see them much better. Yeah. So that's actually one of the nice demonstrations to actually show that it's not those filters are not only useful to add a little bit of color for aesthetic purposes, but that we're actually able to see structures that otherwise we were not able to see. Yeah? With the wide variety of filters, how do you keep track of the most effective filters, or do you have a notebook or good memory? I don't have a good memory, unfortunately. What I usually do is I'm a little bit disorganized concerning this. I just like to do a little microscopy and I just experiment around. Right? And I simply exchange filters and try different settings. However, I did once keep a notebook, and I do recommend that. Some kind of a lab notebook sounds very fancy, but actually some kind of a diary where you simply write down your notes so that you do not keep on reinventing the wheel. Yeah? When I studied zoology and human anatomy, pre-med, we had many amazing prepared slides that were already 30 years old. Yep. Yeah. Can you see those muscles in dark field? Let's have a look. Okay, so I'm going to exchange now the filter with a dark field one. That's now dark field. Okay. And you see, it's kind of interesting. It's in dark field, the insect looks fairly transparent. Yeah, you see. And yeah, so that would be now dark field. I'm going to move this a little bit to add a little bit more light. Yeah. Yep. Yeah, we're also able to see them now. Yeah. But it is not completely dark field. I open it up a little bit to allow a little bit more light to go in here as well. Yeah. Because otherwise it would be too dark. Yeah. So, okay, let me show you a couple of other specimens here. What is this one here? Ah, that's a bird's feather. Yeah. Gallus domesticus. That's actually a chicken feather, right? So let's have a look at the feather. Again, I pre-selected those specimens which basically give you a fairly good effect, but I always have to find them. So I'm not sitting, you see, I'm not sitting behind my microscope. I'm just looking at the computer screen. And here we go. Oh, this is pretty dirty, this one. Okay. So this here is what, that's not the dark field one, right? Okay. So that is now basically a feather, and the accessibility of the filter holder is not quite good. So I'm kind of, and which one's this? Oh yeah, is this the red blue one? Okay. But that's not the one I wanted. It's a blue yellow one, but let's try the other one here. The one which gave me a darker. Okay, that's a little bit better, right? Yeah. So that's again the blue yellow one. Huh? We could also try maybe the green yellow one or the blue red one. Some time ago, what I've done actually is considered to it would be kind of nice to kind of maybe some kind of a do-it-yourself solution concerning for changing filters. So that is now, let me quickly, it's yellow, green, obviously, yeah. So here I think that's again one of those examples. Maybe I'm going to just try to improve the filter a little bit by making the green a little bit darker, okay. Because I do have plenty of additional here to try around. And what about the yellow blue? No, red blue I mean. Yeah. Here we go again. Yeah. Again, the contrast is much better when looking through it compared to what we see here. No, this is not so. Then not quite as. Yeah. So you see that again, not every specimen is entirely suitable. Let me try this one over here because it has this regular pattern. I'm going to try now the one which has red and yellow on the side. Maybe this. No. Nope. Yeah, I think kind of illustrates that not all specimens are equally suitable, right? Yep. I'm reading again here. Yeah. I'm just flabbergasted that chlorophyll stays green after so long. Let's put it this way, I do have a couple of slides where it's actually not the case, where the chlorophyll is kind of bleached out quite a bit. Maybe this also depends a little bit on how well the slides are stored and if they're always stored in darkness. I could imagine. This is a cross section of a dandelion flower. So again, this is in bright field. So I'm going to close down the condenser a bit again, so we see different types of cells here. But there is also somewhere on the side, yes, these things that you see here, you see are those things basically it's the fluffy part of the dandelion. The one that the little tiny little hair, the fluffy part that works like a shoot, so that the seed can be carried away. And the interesting thing here is that they start to shine up first and better compared to the other parts. So look, yeah, it's actually quite nice. You see, or let me remove the arrow again. Yeah. You see that those parts, pick up the yellow color, while the other parts of the specimen, not so much. I like this example here because this illustrates a little bit that even on the same slide, you see the different parts of the specimen interact with the light differently. In this case, now those tiny little hair, they seem to interact with the light much better, and they reflect it much better, but those are down here not so much. Yeah. So I will try to make a rainbow filter. I think that's what I've done is if you have a laser color printer, you might want to. I mean, I have designed those. What I've done is I've in order to get the proper size of the central disc, what you might, if you have a laser printer, then I would do the following. I would first make in PowerPoint. I always use PowerPoint. I would first make different filters with a different sized central patch stop, simply black-white, right? Simply in order to determine the proper size of the central disc. And once you've you swap them out, and if it is not completely dark when you print it out with a laser, then I recommend that you take also a marker maybe and make it additionally darker, or that you stack several of those on top of each other, and once you've got the proper size of the central disc, then you just remember that, and then you can make different color filters as well. You're just using the same dimension. But for determining the size, I think it might be the easiest to simply try to use dark field, because the effect is the strongest. What's the difference between dark field and oblique? Do you have an example of oblique patch stop? Okay, let's put it this way again. Is that you can have, this is a regular dark field filter, right? There are certain filters oblique where basically only one of the quarters is actually open. It's black. Right, and the main light is blocked out in any case, and then you only have light striking from one side, and then it will give you a slightly three-dimensional view. However, I just want to show this to you here as well. If you kind of shift it out, if you just use a regular dark field filter, Rheinberg filter, and if you kind of move it out from the center, and if you have light only coming from one side, like over here, okay, that's better like this. Let me turn up the exposure time a little bit. I'm already at the maximum. Then you will see that it does look a little bit three-dimensional. This is basically called oblique illumination, when the light mostly strikes from one side. Yeah. So, and this is kind of gives a little bit, I read somewhere back in the day, when the microscopes were not able to resolve so well, and the optics were not that great, they used apparently oblique illumination also to see bacteria better, because otherwise they couldn't see the bacteria quite as clearly. Laser printers use opaque toner. Wouldn't an inkjet printer on acetate film be better? You tried out, and what I found out that both inkjet and laser printers sometimes did not give a sufficiently colorful or dark image. So I had to stack them up on top of each other. Yeah. Yeah. So, yeah, so there is some communication going on here as well. So do you have anything left here? This one here is maize. And the maize, and then the last one that I have here is, what is this? Are some starch grains from a wheat grain. Yeah, here again. That is now the maize cells. It's a way too much magnified, I think. See over here, it's again too dark. Okay, so here again you can see that some of the cells, or some of the cells will reflect the light quite nicely, while others here, for example, it's the phloem, not so much. So again, the not all parts of the specimen interact with the light equally. Let me readjust everything again here a little bit. Okay. So these basically these things are so-called the vascular bundles, where water is transported up the maize plant, corn, maize. Yeah? And this is how it looks natively. Yeah, it's a stained specimen. Yeah? That's why there are blue colors and red colors and so on. And that is now with the filter added. Okay. Have you ever tried a filter with 2/3 concentric rings of different colors, basically rings like this? Yes, I've tried it, but I found out that at least in the specimens that I used, the colors kind of got all mixed in the image, so I could not distinguish them anymore. What I, however, have read, but I have not found an ideal specimen yet, is to use filters like this, because you see over here it's red, red, and yellow, yellow, and blue in the center. Because what I heard is that they basically will create images depending on how the specimen refracts or reflects the light, with red in one direction, yellow in the other direction, and blue in the background. Yeah? So if there are, for example, certain repeating patterns, apparently those are also suitable. But I've not found a sufficiently good specimen yet. Yeah? So I was wondering about the difference of perception between oblique from the bottom and with incident light. Okay, don't know so much. Well, yeah. The question, that's something that is quite interesting here. The question was here the following: what happens right now? I showed you oblique illumination with light from the bottom. Okay, but what about if I now shine the light from the top? Okay, like for example, right now you see that it's from the bottom, and it kind of looks a little bit, three-dimensional as well. And I think if you do it from the top, you get an image that looks a little bit more like from a stereo microscope. So it, if if the specimen is very transparent, then it will actually be like this. Then it will appear to be more probably like dark field, where the specimen is brighter on a darker background. I have not tried this yet with all of the specimens, but generally, if the specimen is too transparent, then you're also not able to see quite a lot, because most of the light will actually go through. So this is again, I would say, an interesting question to figure out. Yeah? So this is again a combination between Rheinberg and oblique. Yeah, and it's so much more clear through when directly looking through the microscope. Yeah? So it's 1 hour 23 minutes, and I'm just going to show you the last one. Okay, and that is now a cross section of a wheat grain, and there are starch grains visible. Okay, So these tiny things that you see here are starch grains of a wheat. Let's go up a little bit here again. And they are really, here you do see a really strong oblique effect. Okay. Again, a combination between Rheinberg and oblique. And starch grains of a wheat grain. Okay. When I use polarized filters, are the rainbow colors minerals? I see some microbes have rainbows inside and some don't. It could be that those microbes maybe swallowed some substances that were optically active. Yeah. Will a black ring in between the central blue disc and the red outer ring maybe increase the contrast? So the question is, worth to try out. If you have, essentially, if you separate the ring, the red outer ring and the central disc more by adding here a black ring, if this were to increase the contrast. Something I didn't try out yet, but that's something that I could try. Yeah. So maybe that there is less of a color mixing between the inner and the outer one. Yeah. This could be. Yeah. So where do you buy the filters from and how do I make them? Those filters I got from one of my viewers. Again, thank you very much. And I was told that these filters can be bought also, at least the plastic, can be bought over Amazon. They are also used to, if you have some lamps at home, light, for example, for stage lamps and stage lighting and so on. If you would like to change those colors around, then you can actually use those filters. I can imagine, I'm not sure, but I could imagine then that they're probably a little bit more heat resistant. I don't know, but if they're actually used for lamps, I could imagine. Otherwise, what you can try to do is you can try to use markers and to draw those things on an overhead foil. However, I found out that with markers there are two disadvantages. First of all, you never will get such a smooth, consistent color. So that means when you put it under the microscope, you're going to see that some parts are not quite evenly colored. And the second disadvantage is that with markers you do not get quite of a strong color. So in this case, you would have to stack several of those on top of each other. Yeah. Or what you can try to do as well, I've also done this in the past. Look, this is a 3D printed one. Okay, this is basically blue background, with a non-colored periphery over here. Or you can try to use nail polish of different colors and try to put it on a plastic disc as well. And if you just want to really very quickly experiment with a dark field, then all you can do is you can also cut out this is some electrical tape that I cut out and glued on here, also works. Something that you should please not do, I'm just saying this is a little bit of a warning, especially if you have microscopes with halogen lamps. Because halogen light bulbs are quite bright, very bright, and if you completely want to make it dark, theoretically, you could actually put on a cutout of an aluminum tin can, right? I've tried this once because I really had problems blocking out the light. But I would say you got to be careful with that, right? Because if aluminum tin can is shiny, it will block the light very effectively, but it's also going to reflect the light back directly into the lamp. It acts like a mirror. And this can actually harm the halogen lamp because of overheating. So it's actually, if the filters become hot, then this actually means that the energy is absorbed, right? And you should not reflect it back into the lamp. I'm just saying, because I've actually done this in the past because I had problems blocking it out with my halogen lamp, and then I said, okay, maybe I'm just going to put some aluminum foil or some metal foil over here too, but then this might cause overheating of the halogen lamp. Okay, color gels for stage and cinematography can really take the heat. They change them yeah, they changed them with protective gloves on. Oh, okay, because maybe they become so hot. Okay, so gels, color gels, they're called. So maybe you've, yeah, there is actually, I was also sent a link where these things can also be bought on Amazon. But those filters here I got as a present, and I would like to say again a very big thank you to Hadrian, also in the chat forum here, who made them and who told me that he used a puncher. Yeah, basically, yeah, you can buy those. Yeah, with a hammer you punch them out. And he suggested that if you want to do that, you have to really make sure that you're doing it on a very hard surface, so that you basically are able to punch it out quite nicely. And you see over here that some of those filters can be also fairly thick and fairly solid. Okay. So last comment, this video stream has been really very interesting. Thank you very much and stimulating. I would like to thank all of you also for your comments and your questions. I hope that I'm able to see you again next week. Do leave comments behind. Maybe you also want to experiment a little bit in my other channel called Microbehunter Microscopy, which is a little bit more technical. I did, yeah, also in the past, a couple of years ago, experiment with Rheinberg filters and dark field filters. So if you search there, you're able to also going to find a couple of videos that are recorded some years ago. Yeah. So last comment here, you said at the offset that you have received emails with questions. I found a strange microbe. What email should I direct my query? My suggestion would be, I sometimes also have problems identifying microbes because sometimes many related microbes look, or many different microbes look quite similar under the microscope. So sometimes you need several pictures. I recommend also that you get yourself, if you're interested in this, an identification book. Okay, and then this might also help. Okay, if you want to send me emails, you can send them to oliver@microbehunter.com. Okay, and I am going to really leave it at that now. If for whatever reason I'm not able to do the live stream on a Saturday evening, then I will make an announcement in the community post, and I usually will do that at the same time on Sunday. Okay, but I will try to keep to the Saturday to the Saturday schedule. Okay, I wish you all the best. Happy microbe hunting. As always, see you around next time. Bye bye.